Good morning, everyone. This is the session 5 from the chapter of current electricity. The topic is the drift velocity of electron, and today we will be deriving the equation for the drift velocity of electron when a conductor is placed in an external electric field. So here I have drawn one figure in which this is a small conductor, and this conductor is placed in an external electric field. So when a conductor is placed in an external electric field, the electrons are accelerated by this equation, that is m into a is equal to E into E. Now this E into E is basically the magnitude of the electrostatic force which is exerted on these electrons due to this external electric field. And because of this force, this electrostatic force, these electrons will be acquiring an acceleration which will be given by this formula, that is A is equal to A is equal to E multiplied small e multiplied by capital E divided by m, where small e is the charge of the electron, E is the intensity of the electric field, and m is the mass of the electron. So here, what is m into a? M into a is the force, and this force is provided by the electrostatic force. So therefore, this has been equated here, and we have got the acceleration of the electron when a conductor is placed in an external electric field. Now, when these electrons when they start moving, then they collide with these positive ions or the atoms in random directions. So what happens that their average velocity becomes 0 as they are moving in the different random directions. Now this is one, just take one example here. This is one electron. Let us say this electron collides with this positive ion. So when it will collide with a positive ion, what will happen? Its velocity will become 0. And let us say again, what will happen after the collision? This electron will acquire an acceleration given by this formula, that is A is equal to E, small e into E into this capital E divided by m. And because of this acceleration, it will again start moving in any direction. It can move in any random direction. And let us say this electron now, after colliding with this positive ion, it collides with this positive ion after acquiring an acceleration given by this formula. So in that case, what will happen? That is, here I have written this is the fourth point, that is, after the collision with the positive ion of the atom, the velocity becomes 0, and this electron will again get accelerated by this formula, that is A is equal to E small e multiplied by capital E divided by m. And now if here I have taken, if tau is the average time difference between two successive collisions, that is, if electron collides with this positive ion, its velocity will become 0. After that, it will accelerate by as given by this formula. And again, let's say it is colliding with this positive ion. So if tau is the average time difference between two successive collisions, this is also called the realization time. And tau is something which I have taken because this is normally mentioned in the books also. So if tau is the average time difference between two successive collisions, then using the equation of linear motion for constant acceleration, that is v is equal to u plus at, we will be getting the average velocity of an electron, which will be equal to 0 plus small e multiplied by capital E divided by m into tau. This is the acceleration, and this is the average time difference between two successive collisions. So this is the average velocity of an electron when a conductor is placed in an external electric field. Now so the average velocity of an electron is equal to E divided by m into tau. Now, let us say there are n electrons. Let there be n electrons which are moving in random direction. In the under the influence of an external field. Under the influence of an electric field. See, this is the average velocity of an electron. Okay? When a conductor is placed in an external electric field, but I am considering that there are n electrons which are moving in random direction under the influence of an external electric field. So now each electron will be having its own average velocity. So there is a term called the drift velocity. Now drift velocity is basically it is the average velocity of all the electrons. Average velocity of all the electrons it is the average velocity of all the electrons when a conductor is placed in an external electric field. So drift velocity is the average velocity of all the electrons when a conductor is placed in an external electric field. Now the average velocity of an electron is given by this formula. So this will be equal to L. If there are n electrons which are moving in random direction under the influence of an electric field, then the average velocity of all the electrons when a conductor is placed in an external electric field, which is given by Vd, will be equal to what? The sum of all these velocities of individual electrons, which is equal to what? E divided by m to tau. Now since we are adding up all the velocities of the individual electrons, so what will happen, that this will be equal to into n, when n is the number of electrons which are present in this conductor and which are moving in random direction under the influence of the electric field, divided by the total number of electrons. So finally we will be getting the drift velocity formula as E divided by m into tau. So the drift velocity of an electron when a conductor is placed in an external electric field is given by this form by this formula. And one more thing, the direction of the electric field is from a higher potential to a lower potential. So if the direction of the electric field is as indicated by this arrow, then the direction of this drift velocity will be opposite to the direction of this electric field, because this is the direction of the drift velocity. Because the electrons move from a lower potential towards the higher potential. So the direction of the drift velocity is always opposite to the direction of the this electric field, and in this case, since the direction of the electric field is given by this arrow, therefore the direction of this drift velocity will be opposite to this this electric field, that is, it will be pointing in this direction. So thank you very much for joining this session, and in the next session I will be deriving or I will be discussing about the conductivity of a conductor in terms of the relaxation time, and we will be deriving an equation for the same also. So till then, have a nice day. Bye.